Welcome to Pepcoding. So in this video, we are going to discuss the question of binary tree, which is all nodes distance k in binary tree. So what the question says basically, you will be given the root of a binary tree and the value of a target node target and an integer k. So three things we are given: root and target node and the k integer. And what we have to return? You have to return an array of the values of all nodes that have a distance k from the target node. So what does line 3 means? So let us discuss all these 3 points in our binary tree. So let's move to our tree. So this is our binary tree. And what does question says? We will be given a root and a value, a target node and a value k. So these three things will be given, and what we have to find? We have to find all the nodes, array of nodes which are at distance k. Suppose the root is 12 and target is 8, okay, and k value is given as 3. So what does the question says? Basically, you are given a target node, and what you have to do? You have to find all the nodes. You have to print all the nodes which are 3 distance away from the 8, and also in terms of edges, distance in terms of edges. So if we say node at distance 1 from 8, so that will be 6, 4 and 1. And if we say all the nodes at distance 2, then that will be 1. See, this is 1, 2. Okay, so and in this direction there is only one node, so there is no node at 2 distance. And in this direction, if we move in this direction, 1 then 2, then we have 2 nodes which are 2 distance away from 8. And as we have taken values, target is 8, so our target is 8, and we have to find all the nodes which are 3 distance away from 8. Then what will be our possible answers? Our answers will contain the nodes 1, 2 and 3. Okay, in this direction this is a possible answer, and in this direction 1, 2 and 3. So this will be a possible answer. And if we move more upward, then 1, 2 and 3. So this will also be our answer. Okay, so our possible answer will contain which nodes? 15, 2 and 5. So our answer will contain all these 3 nodes. So what's the logic behind this? See, this same question we have also done in level 1. In level 1, in the topic binary, there was a question: print all nodes k distance away. So in that question also, that is also the same question, but in this level 2 question, we'll discuss more optimized solution. Okay, so we will work in the space. So in this particular question, we will optimize our previous solution. So what we used to do in level 1 question, see, if you haven't watched that video, then you can also watch that video also. In that video, what we were doing, we were finding the node to root path, and then we were printing. See, our node to root path was containing 8, 1, 3 and 5 and 12. And what we were doing, we were printing, we were supposed to print 3 distance away from 8. So if we do the indexing 0, 1, 2, 3, 4, so we were printing 3 distance away from 3 distance down from 8, 2 distance down from 1 and 1 distance down from 3 and 5 distance down from and 0 distance down from 5. So, and in this case it will be -1 distance. So this is the terminating case. So this case will not be considered. Okay, we'll consider all these four cases. And suppose we have to find, we were finding 3 levels down. We were supposed to find 2 levels down. Uh, we were supposed to find 3 distance away from 8. So our for 1 we were finding 2 levels down from 1, means 2 levels down. So which are the nodes that are 2 levels down from 1? Those are 15 and 6 and 4. But 15 can be our answer, but 6 and 4 can't be our answer. Why? Because it is true that 6 and 4 are 2 distance away, means 2 levels down from 1, but it is not 3 distance away from 8. And what we are supposed to do, we are supposed to print the nodes which are 3 distance away from 8. But in these cases, it is only 1 distance away from 8. So we can't, for 1, we can't move in this path. So we were basically blocking 8 for 1. So for 1, blocking node was, B stands for block. Okay. Blocking node was 8. And for 3, blocking node was 1. For 5, blocking node was 3. And for 12, for 12 the distance the distance was becoming less than 0, that is negative. So we can't consider this case. Okay, so let us see, we have discussed the approach. So now let us code for this. So here we will write our code. So this is our function for finding distance k, and we are given root, target and integer k. So what is our first step? Our first step will be, we will be creating a function k levels down. And what we will pass? We will pass root value in this, and an integer k, and a block node, and an answer array list. So this will be root and block. Okay, now we'll check the conditions, terminating conditions, that is base conditions. If root equals to null, or k is less than 0, or root equals to block, then simply return. See, this is the base condition. So what we were doing, if this is the terminating condition, if value of k, these are the value of k, so we were supposed to print k levels down, means 3 levels down, 2 levels down, 1 level down from this node, 0 level down from this node. And if the value is -1, if the value of k is -1, then we have to return. We were not supposed to print any levels down from this node. Okay, and also if the node is block node, then for for 1, block node was 8, and if that node is block node, then we are not supposed to move into that direction. And the other condition is if root equals to null. Okay, and when we have to print the answer, if k equals to 0. Then we have to add value of root in our answer and then return. Root dot left, decrement the value of k, pass the block, pass the answer. For right also, k minus 1, block and answer. Okay. So what this function is basically doing, this function is printing k levels down. So see, what this function is doing. So for k levels down, we have passed a root value. Suppose the value passed is 3. Then what will be the value of k? For 3, value of k will be 1. Let us take some other example. Suppose we have passed the root as 1. Okay. So the root value is 1. And for 1, what is the value of k? It is 2. And what we will do? We will check the condition if root equals to null or k is less than 0 or root equals to block. So for this, block will be, for 1, block is 8. Okay. And we'll check this condition. Then we'll check this condition if k equals to, we will not, this condition is also false, this condition is also false, then call to left, then root dot left, then we will come into this part. Okay, 8. Now value of k is, 2 minus 1, 1. Okay, here value of k is 1 and blocker node is 8 itself. So what we will check? We'll check whether this root, now the root dot left is 8. So now this time this is 8. And we'll check if root equals to null or k is less than 0 or root equals to block. So this root is block node. This 8 is block node. So we will return from here. Then we will make right call. We'll make right call. Now the root value is 11. So now the root value is 11. Value of k is k minus 1. Initially it was 2. Now it is 1. And blocker node is 8. Now we'll check the condition. This condition is false. So we'll come in this. If k is equals to, this condition is also false. Then we'll make left call. So here, from here, left call will be made. So while making call to left, this will be null and this will be 0 and answer block is still 8. So when we'll pass null 0 8, now we'll pass null 0 8. Now we'll check this condition, root equals to null. Yes, this condition is true. K is less than 0. See, this condition is true. If either of this condition is true, then we will just return from here. So we will return from here. Then we will make right call. Then root dot right will contain what? Root dot right will contain 15. So root dot right will contain 15. K value will be 1. Initially it was 2. K value will be, k value will be 0. K minus 1. So k value will be 0. And block will be 8. So it will be still 8. Now I'll check this condition, root equals to null. So this is false. K is less than 0. This is also false. So we will come in this condition, root is equals to block. This is also false. We'll come in this condition if k equals to 0. Yes, k equals to 0. Then what we'll do? We'll add this value. Which value? Root dot value. What is root dot value? This is 15. So we will add this into our answer. Our answer will contain 15. Now we will return from here. Okay, now we'll simply return from here and we will return from here. Okay, so this is how it will work. Now our next step is this we have done for function of k down. Now we will work for this function at distance k. So what we will do over here, firstly we will create an answer array list to store the answer. This is empty array list, new array list of integer. Okay, and we will create a function from here which is distance k. We'll call this function. What we'll pass, we'll pass the root value and target value and value k and also our answer array list. Okay, from here we'll return our answer. So what we'll pass, we'll pass root value. So basically we'll be passing all these parameters in our distance k function. Okay, so int k, sorry, it is target. We won't be passing block. So we have passed root value and target value and value of k and array list of answer. Okay, so our very first base condition is if root equals to null, then return -1. If root dot value equals to target, then we'll call the function k down recursive function. We'll pass root comma k comma null, because see, we will call this function k down. If root dot value equals to target, then we have to call the function k levels down, and for that value of k will remain k. We won't be decrementing. See, for this value of k will remain k, which was the was initially 3. So our next condition is, firstly we'll find the left distance. Root dot left, and k value will become k minus left distance. See, in this function we won't be using any extra spaces except the recursive space, because we are working on this distance function. Ultimately this function will a substitution for node to root path. Okay, this is a substitute for finding node to root path, which was taking extra spaces initially. Node to root path function was taking extra spaces, so this is the more optimized way and a substitute for that function. So we'll find k down This will be root. Okay, so this was distance k, this was target. This was target. This was value of k. This is distance k function. Okay. So this will be target. This is k. Now we have called the function k down. So k down function will have root dot left, root comma k minus left distance. K value will become k minus left distance, and target will be root dot, blocker node will be root dot left, and we will store the answer in this. Return left distance plus 1. So our next condition is for right distance. Copy the function. This is right distance. This will be root dot right. See, if you are not getting this thing, then we will be doing dry run of this, then we will be getting more clearly. Right distance, and this will be root dot right. This will be RD plus 1, return minus 1. So this is the function of distance k. So let us do the dry run first. I hope it is visible. So let's do the dry run for this. In this, initially root value will be, so this is value of k. Initially the root value will be 12, and let us mark these statements as 1, first condition, second condition, third, fourth. Okay, so initially the root value is 12, target will be 8, and the value of k is 3. So our first condition will be checked, which will be false. Second will also be false. Now we will make call to third. Okay, so distance k function will be called. We will call to root dot left, and then again now for the next time, root value will be 5, target will be 8, this will be 3. So now again first and second condition are false. We'll jump into left. Now this will be 7, 8 and 3. Then again we will make call to, we'll check first, second condition, this will be third. So we'll check, we'll jump into this third, we'll make call to third statement. Now the root value will be root dot left is null, target is 8 and 3. So we'll check first condition, which will become true because root equals to null. Then we'll return minus 1 from here, and this will get attached to LD. So here LD will be minus 1, and then if LD not equals to minus 1, then only will come inside this if condition, otherwise make call to right. So we'll call for right. Here also this will be null, and this will be 8 comma 3. So here also first condition will be true, we'll return minus 1, and this minus 1 will get attached to RD. So here what we have got, LD equals to minus 1 and RD equals to minus 1. So here LD equals to minus 1 and RD equals to minus 1. After this, what we'll return? We'll return minus 1. So we have covered all these 4 conditions, 1, 2, 3, 4. So we'll return -1. Okay. Now this -1 will get attached to LD. So here LD will receive -1, and then we'll make call to write. So for write, this will be 3, 8, 3. Okay. Again, we'll make call to left. All first, second condition, all are false. Then call to right, left. Then here it will be 2, 8, 3. So here also we'll check all first, second, third condition, and we'll make call to left. From here also -1 will get returned to LD and RD. Okay. So here also we'll get LD equals to -1, RD equals to -1, and after making all left and right, we'll return -1. So this -1 will get attached to LD. So this will be LD equals to -1. Then we'll make call to right child. Okay, so from here right call, it will be 1, 8, 3. All first, second, third condition are checked. Then call to left. Then this will be 8, 8, 3. Then first condition will be checked, which is false. Then second will be checked, which is true, because root dot val, which is 8, equals to target, which is 8. So what will be done? So from here k down function will be called. And what k down function was doing? K down function was taking root value and k value and blocker node was giving the answer. So from 8, 3 levels down, this 3 levels down, and no direction is blocked. So, and there is no node which is 3 levels down from 8. So our answer will contain nothing from here. So answer will have nothing from here. Okay. Now what will be done? From here, we will simply return from here. See what we'll return. We have skipped the condition. We'll return 1 from here. Okay. So let me change here. So here will be return 1. Okay. So then 1 will get returned from here and will get attached to LD. So this LD will equals to 1. Okay. So now this condition will get checked. If LD not equals to -1, then call this function k down, and this k down will contain root, which is 1. Here root is 1, and k minus LD. K minus LD, here k is 3. K is 3, 3 minus 1, which is 2, and root dot left is, what is block? This is blocker node. This is blocker node, and blocker node is root dot left, which is 1 dot left, which is 8. So this will give me what? This will give me 2 levels down from 1. 2 levels down from 1. What are the nodes which are 2 levels down from 1? 6, 4 and 15. But one more condition, 8 is blocked. So this direction is blocked. Then 2 levels down from 1 will be 15. So our answer will contain 15 from here. Okay. So our answer is containing 15 from here. And what we'll return? We'll return LD plus 1 from here. So